yesterday.
See,
Okay, no
the
problem.
question is, what are the available satellite data sets which are freely available to download? We need the specific name like Landsat 8, Landsat 7, Landsat series, or Sentinel 2, or List 3, or Cartosat, or any other data set that are freely available to download with their country of origin. Okay, so country of origin for Landsat series is United States. Country of origin for Sentinel 1 and 2 series is European Space Agency. For List 3 it is ISRO, Indian Space Research Organization. List 4, Indian Space Research Organization. So List 4 is not an open source data right now. It will be in the future in upcoming months. So that was the list that we required. I think you all forgot about the assignments. So
Sir, we were confused by the question.
okay, now you're clear.
Now,
Yes, sir.
So you will do it today, and with the additional assignment that will be giving it today. Okay.
Okay, sir.
and
Sir,
then
can you
what about you three guys? I have asked about image interpretation keys. Speak. Just tell me in one word what is the difference between element and key. Hmm.
Good morning, sir. Good morning, everyone. So, image interpretation, we can actually examine the identity. We can identify the objects, or we can judge their significance. And so, for the image interpretation, we can do some activities like detection, recognition, and analysis, deduction, classification, and idealizations.
No, these all comes under this element only.
Yes, sir. So now I am telling about the
Huh,
keys, sir.
key.
Sir, as we know, interpretation keys help us to interpret or organize the information present in image form and guide to the correct identification of unknown object. So there are two types of we can do classify as a two types. This one is selective keys, and one is elimination key. So I've got these two keys, sir, in image interpretation.
Okay.
So after that we can divide the selective keys as essay key, file key, photo key, and integrated selected key. And under, sir, elimination key we can divide into three types. One is Dix key, and one is Punch key, and one is dichotomous key, sir. These are the keys that I have
But
got,
in
sir.
simple word, what I will say, this key. You too. Then I'll say.
Sir, the criteria for identification of an object with interpretation elements is called interpretation keys.
Okay.
So same as her.
So you all copied from each other.
No, sir.
Okay. After the completion of this session, I will tell you about the keys. What are the basic keys and how we use them in our image interpretation. So after this session, we'll have a small talk on that.
Okay. Good morning, all of you. For on day 3 of the 3-week summer training on geospatial technologies. So this 6 students who have joined us yesterday, and this is their first day today. So Northeast Center for Technology Application and Reach is headquartered at Shillong, at currently at Survey of India campus, Bonibray State, and we also have an office in Delhi at Vishkarma Bhavan, IIT Delhi. So this is for the students who have joined today, and also for our guest speaker today. We are Northeast Center for Technology Application and Reach. We were established in 2014 by merging the two existing missions, Mission for Geospatial Application MGA and NMBA, National Mission for Bamboo Applications. We work in several technological sectors. We are one of the unique science and technology institutions across the Northeast. So our basic aim is to provide more livelihood opportunities and to generate more revenue opportunities for the people of Northeastern through the technological intervention and support. So we work across various sectors: bamboo and allied activities, geospatial activities, water and flood management, communication and information technology, agriculture and food processing, livelihood development activities, health and related activities. I haven't went into much detail about the Nectar because some students have already informed me that they will be joining today. Nectar is actually we are one of the funding agency to fund any kind of project coming out of 8 northeastern states. So our basic aim is to promote more entrepreneurship across northeastern states. So any of your students who have joined us, joined us for this training program, might be a future entrepreneur or budding entrepreneur. So in case you need any technological help while establishing your business or your small startup, you can come up to Nectar with your proposal. We have a portal on to present at our website itself. There you can submit your project proposal, and we have a committee, screening committee. The committee screens out the project based on to the viability and as per the mandate of the Nectar, and then we fund. So there are two ways of funding. One is 100% grant that we give. The second is loan. So it is a 0% interest loan that we give to certain entrepreneurs. So our basic aim is whosoever the entrepreneur is, he should be able to provide more employment opportunities to the other northeastern people, at least 10 to 15 people. If one is providing, then we are serving our purpose. And so this is for today's agenda. Today we'll be having a basics of digital image processing. We are having a guest speaker today. He is with us for 2 days. So in the theory session, we will be briefly covering the basics of digital image processing, followed by the continued theory session of digital image processing. Then we will be having the practical sessions of the theory that we have covered. We will also be covering the band indices, band ratioing, and all those things which I was talking yesterday to increase your image interpretation skills. So about today's speaker, he is Dr. Rakesh Mandal, Assistant Manager, Hexagon Geospatial. Hexagon Geospatial is one of the leading pioneer industry developing the remote sensing and image processing related softwares. So they are very famous, and the most used software for remote sensing and digital image processing is ADAS Imagine. I have been using that software for the last 5 years since I have started my career in the field of remote sensing and GIS. And he has done his masters in remote sensing and GIS from North Odisha University. He is having a PhD in health GIS from University of Kolkata. You can see again a unique field of GIS even in health sector also. He is having more than 10 years of experience in various application areas of remote sensing and GIS. He has worked with several government and reputed institutions such as IIT Kharagpur, ICMR, RMRI, CDRI Lucknow, IIT Banaras. He has also published more than 20 research papers in national and international journals. So today we have a person who has experience of both research as well as industrial experience. So I think you all have a very good and wonderful opportunity to learn from him. He is with us for today and for tomorrow's session also. Tomorrow he will be taking the basics of image classification. And now I hand over the mic to Dr. Rakesh Mandal. Thank you all for joining us. Before starting up the session, I request Sri Dharmendra Jha, Senior Analyst, to facilitate the guest speaker today in the traditional Assamese style. Thank you, Dharmendra ji. Now I hand over the mic to Dr. Rakesh Mandal for the session to start. Thank you all.
Thank you, Mr. Satyam and Dharmender ji for calling me to here to deliver this lecture on digital remote sensing and the classification, and also I will show you some recent trends in remote sensing and GIS, how the remote sensing data is being used for the industrial purpose and the research purpose. So thank you very much again to all of you, and welcome to the today's training program. And before coming to the training subject, I would like to give you some basic insight about our hexagon. What is hexagon? So hexagon is a leading industry. We having the solution for everything. You can say everything in one words. Whether you are belonging to, you can see here we have the technology solution provider, global research, R&D focused, everything. So it's not marking over these slides. So the data production, like we are providing the CAD, BIM, GIS data, photogrammetry, surveying and cartography and sensor related everything. So we have the platform, software as a solution, software as a platform, and if you have anything like you need the solution, suppose you are coming from the forestry background or you are coming from the agricultural background, you having the project on health GIS, you having the project on multi-city management and the smart city management. So once you come to us, then we will give you also the solution on this platform. So then you can see here the agriculture, aviation industry, defense industry, these are the user. So we are everywhere in the government sector also as well as in the public sector. Now as a software, we have the product of GIS software like GeoMedia and the remote sensing software, that is one of the raster image processing software which is since 1980s. So ADAS Imagine is the only de facto manufacturer of this, one of the best product, and it is being used in the industrial as well as in the everywhere. So if you coming for any type of remote sensing data analysis, then we have only the ADAS Imagine. And now we have some additional software with this Imagine photogrammetry. So I'm telling or I am giving this information because you are coming here for the geospatial training. After the training, we will be somewhere in a company or in a public sector, in a government sector. So you should have some knowledge about the remote sensing product, because you have the satellite data. Satellite data are now easily available. You can download from, like you are telling that USGS, Earth Explorer, and there are so many sites are there like Bhuvan, ISRO. Okay, so you can, once you have the internet access, you can log in on that platform and you can download the data. So satellite imagery is now available, but you have to learn how to use and how to generate the product from these satellite imageries. So first means we are the first commercial remote sensing software like ADAS Imagine, and the first commercial 3D viewing application. We have near real time dynamic queries. We have first geographical interface for building flowchart models. Suppose if you want to analyze the data using the tools, you can do using this ADAS Imagine software, as well as we have the platform for the spatial modeling also. Somebody is coming from the, like he has the experience on Python, so you can use our facilities also. And if you don't have any knowledge about the any type of language like Python, C++, no issue. We have the tools also for creating the models. So ADAS Imagine is a very basic and very standard, you can say. You can use this software for everything. So thank you. Now I am coming to the subject, which is the subject is to deliver the lecture on digital image processing and georeferencing and rectification. So we have the 2 theory session that is on basic digital remote image processing, and we will continue to up to 11:45. Okay. It's about the remote sensing data, how this data is being collected, and what type of modes and platform is being used for remote sensing data collection. Although I am not having any interaction with you like introduction, okay, so I will do it again in the later session. Okay. So anybody have any knowledge about remote sensing? What is remote sensing? How the satellite data is being collected? You can say. Yeah. Okay. Now, first of all, I want to know the what is remote sensing basically. What is remote sensing? Answer is in the words. The remote sensing, okay, no issue. If you don't know, then don't know, no issue. So I will tell you. So what is remote sensing? The term of remote sensing literally means sensing at a distance without being in any physically contact in between the object and the data collector. So whatever the information you are collecting, it will be from the distance, and it may be from the sky level, maybe from the ground level, maybe from the somewhere in between the air level. You are telling about the ground borne remote sensing and the space borne remote sensing and the airborne remote sensing. Am I right? So everybody is knowing that these things. So if you have some satellite data, then we have to know how to interpret the data. You having the session last 2 days in how to interpret, what type of elements you have to use for interpretation purpose. Am I right? So you have the knowledge about this. Now, when I am going to the what's interpretation, then the data may be a satellite imagery, may be some statistical data, everything can be interpreted. Suppose you have a long database and you have a rich database, you have some satellite data, you have some photos, somebody given me a photograph of your teams, and then if I want to understand the who are they and who are these people, what are their name, then I have to interpret the image by face or every whatever the key elements I will be using for interpretation. So suppose you have a statistical data and you have a satellite imagery in a photograph, so we will go for the interpretation for characteristic, some generate the data about this photograph or the data, or it will be a satellite imagery also. So there are 2 types of basically interpretation technique we are using. One is visual interpretation and another will be the digital interpretation, digitally, that can be done digitally. So our subject is digital image, but why we will go for the digital image interpretation? Then when we having the visual, we can do these things in visually, then why will go for the digital image interpretation technique? Why will use? So there are some problem. When you interpret the data visually, then you can have some disadvantage. You may have require extensive training, and this process also labor intensive. And you can see that using our eyesight we cannot able to interpret everything. So that's why we are using the satellite sensor to collecting the data over a electromagnetic spectrum. Remote sensing data is being collected using the electromagnetic spectrum, but our eyesight only able to understand the things in between 0.45 micrometer to 0.7. So that is only the visible remote sensing. Okay. So this is also known as the optical remote sensing, and that's why to interpret the data in a better way, we are taking the digital we are taking the advantage of digital image processing techniques, and that will be using this type of digital remote sensing software like ADAS Imagine. And if you go for the E3, then E3 have the different type of software also there. E3 have some ArcGIS software for GIS data generation. Okay. Now I hope that you already have seen the satellite data, how it's look like. So satellite data having some specific points and for specific features. That's why we are able to extract the information or do something research on this data to extract the information for the product development. So you can see there are 4 samples of satellite data. One is for the first imagery is in the true color, then the RGB, and then the panchromatic band showing, and it is a thematic the product, final product we have developed using the level slicing, density slicing of a DEM, digital elevation model data. Okay. So what is image data? These data are organized in a grid of columns and rows, usually represent a geographical area. So somebody is telling about the geographic data, then you have to understand that this data should have some latitudinal and longitudinal graticules, and each graticules having some value, that is called the DN value, digital numbers, and these digital numbers giving you the representing the each earth surface features. So suppose if you have a satellite imagery that will cover different type of earth surface features, and due to the reflection and variation in the reflection, there can be these features can be identified using this satellite data. Okay. So digital image having some sampling and quantization of the 2-dimensional real image both in spatial coordinates and the brightness. So digital image have X, Y and the Z value. Okay. So Z value, it may be the elevation value, or otherwise these graticules have some values. This is called DN value or digital numbers. So when the satellite data, so it is a basic definition for you, for your understanding purpose only. So what is digital image processing? Is a group of process that involve to manipulate the digital data with the help of the computer hardware and software to produce digital maps in which specific information has been extracted and highlights. So I already told you that suppose if you have a remote sensing data, if you want to develop some product, then you have to, for the interpretation purpose, we have to generate the data quality, then we will go for the digital image processing. If you have any question, then you can directly ask me, okay, also during the presentation. No issue, I am comfortable. Yeah. So one of the best example you can see here, that in 1920s newspaper industry is trying to use the digital image. So how it's look like that? Is it clear? The image is not clear. They are trying to develop some digital image. So that is the basic level. Now we have the satellite image, and that is very much clear in compared to this image. So So use of digital DIP, the concept of DIP still in there in the 1920s, but for improving these images there is no technique, such techniques like hardware and software. Suppose I am telling that today I am here to telling that we have the software, they don't have any software, they just print out, and they have used the basic concept for developing this DIP, digital images. So why we will go for DIP? When the remote sensing data is giving everything, all information in your data, and data is clear, then why we will go for the, no issue, you don't take the photograph, I will provide you the whole slide, okay. So that will be easy for everybody. So when the remote sensing data is being collected, there will be some issues, like you can see here some radiometric problem, some atmospheric problem, geometric errors, earth rotation. So due to this problem, there will some interruption in between the data collection. You know the remote sensing data collection process, there are two processes basically. One is active remote sensing and another is passive remote sensing. So most of the cases data is being collected and the available data are passive remote sensing. Can you tell me some example of the active remote sensing system? One example. Okay, no issue. If you don't know, then clearly speak out. Okay, sir, I don't know. Please tell us that what is active remote sensing. So passive remote sensing, active remote sensing, you can see there is some platform that is known as satellite. Okay, and satellite is not able to collect the data. So satellite having some sensors. What we are telling that list 3, list 4, you are already interacted with this session. List 3, list 4, thematic mapper. So Landsat, Sentinel, these are the satellite, and these have some sensor, and these sensor are based on the design based on the electromagnetic spectrum. When you go for the satellite data, you might be seeing that some bands are there. What is this band? So these bands are very specific. I am telling that human eye is not possible to identify or cover all the characteristics. Suppose I am saying you that your shirt color is blue, but if you using the remote sensing sensor, that the information is be very much specific and enriched in a broader level. So I am able to collect the data on the visible remote sensing system, that will be used for the blue, green and red band. But if you go for the satellite data, there will be you will see that there will some band, that near infrared band are there. So this sensor are able to also detect the data using this infrared band. Suppose if you use the blue band, so there will be a reflection curve, and if you go for the red band, there will also be a reflectance curve, and if you go for the near infrared, thermal infrared, in this way for the microwave also, so there will also be. So information that will be collected using the different band, that will be very different for each band. Am I right? You are getting my point? And that's why remote sensing data having some bands. So distortion would diminish the accuracy of the information extracted and reduce the utility of the data. So when you suppose you have a remote sensing data and these data are distorted and having some striping and some information is missing, so you cannot use this data for the final product generation, because accuracy of the data and those product will be generated using this data will be accuracy level will be not at that level. So you cannot say that these features are this and these features are will be some ground features like agricultural land and maybe the forest land and whatever the information is there. So basically in summary, in one words, you can say that the low quality and the distorted of the images required to the development of processing techniques and to make this image useful, and that's why we are go for the DIP. And this digital image processing, basically in the broader sense, this will be two types. One is the pre-processing, another is the image processing. So under the pre-processing, there is many processes are there pre-processing, like radiometric correction, atmospheric correction and the geometric correction. These points are very important. When you go for analysis the remote sensing data, you should have some knowledge about the what is radiometric correction, what is atmospheric correction, what is geometric correction, and why we need this type of correction. So remotely sensed raw satellite imageries normally contains some flaws and deficiencies received from the imaging sensor. I already explained you. On the mounted on the satellite, and the correction of deficiencies and the removal of flaws present in the data through some methods, and these are the radiometric correction, atmospheric correction and the geometric correction. So what we will do using the radiometric correction, basically in the radiometric errors are caused by the sensor electronic or electrical noise, okay, and effects due to presence of atmosphere. So radiometric correction is related to the atmospheric effects. You can directly say that it is due to only the atmospheric effects and some distortion which having in the sensor. Suppose some of the part, that is charge coupled device in a sensor, in a certain time it's stop working, so the data during this period will be missing in the imagery. So you can see there will be a strip or lining in the image. Some data will be there, but some data will not be there. So if you, using this type of data, you will be we are able to develop some standard product. We can do, or we can use this data for the product development. We can't do because some information is missing. So radiometric correction are these, the correction for missing lines, correction for periodic lines and random noise correction. These are the some example. You can see that there is a left side, in the left side image there are some dropouts, line dropouts, and in the right side image there are periodic line dropouts. So this type of data will come, okay, when suppose you are at the basic level, you will be using some data or you will be downloading some data for a certain period of time. But if you go for a project, then you have to monitor some things like how is the vegetation growth, what is the agricultural type there. So you have to go for temporal analysis, and that time you have to use the multi-sensor or multi-dated data, and that time you have some data like this. So each and every data is important for us during this period, okay. So whether this data is clear, so that is best, and if some data is coming with these lines and striping and the cloud coverage, then we have to correct this data, we have to improve this data. Yeah, please. Yeah, restoring periodic lines means this data, when this data has been collected, this time the sensor is not work for this particular line portion. So there is push broom and across broom. So when the data is being collected in this way, so in a certain period of time sensor does not work, and that's why data is missing and some white striping is coming in the data. Sorry? Yeah. Yeah. So after the correction you can see that there is no line stripping is there. Now I am coming to the atmospheric correction. Why we will do the atmospheric correction? Do you have any knowledge about atmospheric correction? Why we will go for the atmospheric correction?
Because there are some scattering from the atmosphere.
Yeah.
Radiations coming from
Actually think that when you collecting the data using the remote sensing system, so that is not the ideal system. Ideal means everything is okay, there is no disturbance in the environment. So what I am saying, that will be happen, but it does not happen in the remote sensing system, original remote sensing system, because in atmosphere there will be some gases, there will be some particles. So sun is only the universal eliminator. So using the sun rays, that sun rays will be used to eliminate or illustrate the ground features. So sun rays is coming through atmosphere. So during this period, whatever the sun rays is coming through the ground, it is not the 100%. Some is being interacted by the particles and gases. So different, so the 100% sensor is not getting the 100% reflectance value. Sensor always getting some 50 to 40% or 60% reflectance value from the ground features. So that need to also be during the remote sensing data processing, we have to correct this type of data. There are some example you can see due to the sunlight, skylight and the path radiance and the scatter of reflectance, this type of reflectance are there. That's why some features will not be identified, you can't able to identify using the satellite images. So we have to go for the atmospheric correction. And another thing is that atmospheric correction also converting the digital numbers to a reflectance value. So you have to learn, when we have a satellite data, you have to, this may be in the digital numbers, then digital numbers should be converted into a radiometric, okay, and then radiometric numbers will be converted into the
I have a question.
reflectance value.
Means, how you process this data? Means that atmospheric correction.
Yeah, we have some tools in the software.
Actually,
Okay.
as I know, we have to go for adaptive optics to remove the atmospheric correction, or some mathematical solutions.
Yeah,
like,
you are
Gaussian
right.
distribution.
You are right, that is the basic concept, okay. But nowadays remote sensing and GIS software like ADAS imagine, we have reached that level, we don't need to go for the manually. We have everything in the software, and once you give the input of this data, software will do the things. So in between the rest of things will be gone. You don't need to go for the other things, okay. So for your knowledge, and you should have some knowledge about this, what is atmospheric correction, otherwise you will be unable to give some inputs
Yeah,
of the
actually I
data.
tried, in solar data. Actually, my background is astrophysics.
Okay. So might be some different process you are using, but in remote sensing data we are using the for atmospheric correction for this purpose only. Yeah, you are right. So in atmospheric correction, basically what we will do, atmospheric correction converts the raw pixel values to a quantities with a physical meaning. So I am telling that there is digital numbers. Using digital numbers, we are not able to understand what type of features is there, whether it is a vegetation cover or it's a bare land or it's some roads, water bodies. We are not able to do it. That's why we have to convert this DN number to a reflectance value. And this atmospheric correction are doing this type of job, like using, if you go for the ADAS imagine, we have 3 models. You can see that this is being highlighted ATCOR workflow for the imagine. So some data would have some ATCOR DHAS and ATCOR 2 and run ATCOR 3. So these are all algorithm based model. So there is some purpose why we develop these 3 models. Suppose there is thin cloud cover in the data, then we will go for the first model, run ATCOR DHAS, okay. And if you have some others problem like I am coming to this haze removal ATCOR 2 is the version which is choice if the terrain covered by the imagery to be calibrated almost flat or you don't have any digital elevation model. So during the atmospheric correction we need the elevation data also. So if you don't have the elevation data and the surface is flat, then we can go for the ATCOR 2, okay. And ATCOR 3, you having the digital elevation data and you have a satellite data, so we need to put the pixel in a exact position, then we can go for the ATCOR 3. So these are the different type of algorithm is being used under this name, like haze removal, ATCOR 2 and ATCOR 3. And that is one of the example, and is coming from the Sentinel-2 data of San Francisco, and left side image is the raw imagery, and you can see after atmospheric it is look like it is very clear, and now the information you can extract the information under this cloud cover also. Now I am coming to the one of the important things, that is geometric correction. Geometric correction means the data should be geometrically corrected. Geometrically corrected means some image having the map data. If you open a I mean that you have a data that is only in the JPEG format and that is not georeferenced with the XY location. You can see when you opening the data in a software, you will see that some map value. So this map value should be converted into the XY location. So the latitudinal and longitudinal, each pixel is a, whatever the imagery you are seeing here, it is a representation of a group of pixel. So pixel is the smallest element of a imagery. Pixel is the smallest element. Suppose if you go for some interview, they will ask you that what is pixel? Pixel is the smallest unit of a satellite imagery. So this contains some information, and that's why you are able to see this information. So when you grouping the pixel, we are able to identifying this the ground features, different type of ground features, and each pixel contains DN number, digital numbers, and these digital number is being converted to the reflectance value. So basically we will go for the geometrical correction when we have a data to remotely censored data and to remove the geometric distortion, so that individual picture elements means the pixel, are in their proper planimetric map location. And what is the planimetric map location? That is the XY value. XY means one is latitude and one is longitude. So during practical session we will do this in our ADAS imaging software. So why we will do the geometric correction? To impose actual ground coordinates, that is X, Y and Z on and the image map. So what does it mean? Means कि आपके पास एक सैटेलाइट डेटा है और आपके पास एक मतलब कि जो जियो रेफरेंस नहीं है, जिसके ऊपर हम एक्स वाई लोकेशन को आइडेंटिफाई नहीं कर सकते हैं, ठीक है। ये एक पेपर मैप है, इसके ऊपर कुछ मान लीजिए एक फोटो है। इस फोटो में अगर कोई बोले कि आप गुवाहाटी में नेक्टर को आइडेंटिफाई करके दिखाइए, इज इट पॉसिबल? यू मे पुट ए पॉइंट ऑन दिस इमेज, बट that does not representing with the exact location. So for this exact location we have to do this geometric correction. We have to put each and every pixel in reference to the ground location. So I will have some GCP, that is known as ground control point, and using this GCP we will convert this image in a resample image in a georeferenced map. So once you done this process, then you can able to identify the exact location of this nectar. So there are some process also. This is also known as the georeferencing, image registration and the rectification. So you can see here some distortion, example of some distortion. It may be during the, this type of error may be coming from the ground features. Suppose you have a ground features, you are taking the picture of a some of the flat land. This picture is having the some parts of flat lands and some have the hilly region. So during this period, maybe the you are getting from the left angle, then right angle, in the right angle there will be some shadow. Okay. So due to the shadow, you are not able to identify these features where shadow will come to there. So shadow will suppress some information during the data collection. So that type of information we have to correct. We have to give exact angle so that we can identify the features, or we cannot miss any information from the image. It may be a scanner, due to the roll distortion, and it may be due to the crab distortion and the pitch distortion. So these are the example. You can see there, if some distortion is there, how the photographic plane will be look like that. If you have some roll distortion, so the imagery having this. So here we have an example that you can see in the left side image, we trying to superimpose the corrected image and the original image. original image in the dotted line. You can see this line look like that in a rectangle shape, in tilted shape. Okay. After giving the geometric exact location, that was fitted, and the mean of the pixel is being shifted. And this is one of the example. We have a satellite imagery of thematic mapper, and this satellite imagery already coming with some georeferencing information, and I am trying to superimpose one of the paper maps, and using the coordinate of this thematic mapper I have been georeference this paper map, and that's why I am able to show you this superimpose the satellite paper map on the satellite imagery data. So why we will do this? So suppose if you want to generate some maps, some kind of map, some kind of features map, somebody will tell you that the guys please make a or develop a database which will only having the information about the road and having the information about the how the water body is specially distributed. So you have to go for you have to use this type of paper maps also, because we already identified data. You just put your point in this map and you can digitize. You can digitize these features using point, polygon, shape. You already have this type of this session, na? Point, polygon, how to create the point, polygons and the layers in a GIS system. So once you done this geometric correction, then only we able to do this or develop this type of features. Now you can see that there is a original image which is not planimetrically corrected, and in the right side there is a planimetrically corrected image. So image is just a image. Okay, you can see that the road is in the not in the proper shape in the left side image, and after giving the ortho rectify the image, you can see that edge of the road is in the proper format. So you can, if you have some linear features, you have, if you want to identify some river lines and anything, then you have to ortho rectify the image so that you can exact or extract the exact characteristic of these features. So that's why we are going for the planimetrically correction of the data. Sorry. Suppose you have a imagery that is in the JPEG format, and you have not given the georectification any information. Okay. So this imagery only imagery for the looking purpose, and for suppose somebody want to some samples of the data, then you can do this. But if you want to generate some kind of line features, road features in the GIS format, then is it in the correct format, the road in the left side image, not in the correct shape. Although it is not visible properly from there, but some road, one road is there. So after giving the coordinate value, some road is there in this part, but it is not visible. After giving the coordinate value, you can see that the road is in the proper format. So that's zigzag and the serpentine characteristic of this road now can be extracted using the digitization. Now we can digitize to extract this feature. Is it? Will you able to do this here? And that's why doing. And other things, if you go put this image in the 3D format, you can see this type of look will come automatically. So planimetrically correction means कि कोई लाइन फीचर्स है, कोई रोड फीचर्स है, अगर उसके बारे में हमें कुछ करे मतलब एक ये इंफॉर्मेशन एक्सट्रैक्ट करना है, वहाँ पे हमको प्रॉपर शेप में लाना होगा उस फीचर्स को, सो कि हमें कोई भी एंगल जो भी है उसको हम एग्जैक्ट तरीके से वहाँ से निकल सकते हैं. Now this will be more clear here, the orthorectification of image. You can see that I already given the example that gather the coordinates. Somebody is telling you that please collect some point from the imagery. So you have taking some points from the imagery, but it's giving the map coordinate values. But once you have georeferencing, you perform the orthorectify of the image using the DEM, digital elevation modeling. Do you have seen any kind of data like DEM? So during the orthorectification, we need the satellite data as well as the DEM data. So satellite data having the information X and Y location, and DEM will give the additional value of the Z location. So that will give a 3D view of the imagery. So here errors are caused by the scale variation, sensor altitude orientation, internal sensor error, and after the orthorectification that will minimize the. Basically, if you go for a flat region, then I already told you that we can use the ATCore 2 model. Okay. Suppose if you have some parts in the hilly region and exactly all features are in the hilly region, then we have to go for the ATCore 3, and then this type of orthorectify is necessary for this image. Now this is very important. When you go for the orthorectification or georeferencing of the image, then you are giving some coordinate values to the original map. So when the resampling process or algorithm is processing the data, some error will come, and that may be, you can see here there is a X residual in the left side image. These are the actual location of the points, ground location point GCP, and here after the correction the image orientation has been changed, and this image orientation exactly fit the ground view of the data. And now you can see there, when you use this resampling method or the georeferencing method, there will come some error, because whatever, if you put your data there, after resampling it will shift to somewhere, and these errors should be minimized at the minimum level. So here is one concept that is very standard, or thumb rule. You can say that thumb rule for the data processing. If you go for a spatial resolution of 1.5 meter data, then your root mean square should be at the half of the pixel value. You should note down it, half of the pixel value. Root mean square, yeah, please. Okay. Root mean square is basically converting, when you converting your map coordinates to the ground coordinates, there will be some error due to the algorithm, different type of error, because we are resampling the data. We are not exact converting the exact data. Suppose you are giving the input in the coordinates point, so that image again will be resampling. So whatever the image in the right side, this is the resample image. So during this resampling process, the exact location of the XY location where you have given your input, that will be shifted somewhere. Okay. So the error in between this, you have given your input here or here, and now you can, after process, this point is shifted to somewhere. So we have to drag this system again to here. So that's why some error will come to there, and this is known as the root mean square. And how will you measure this error? So it will be measured based on the image projection and the spatial resolution. Spatial resolution means ki pixel size. Suppose you have a satellite data of 1 meter, 2.5 meter. If you go for the least 4, then you have the spatial resolution 4.8 meter. So this shifting should not be greater than the 4.8 means 2.4 meters. It should be minimized at the as much as possible below the 2.4 meter. So guys, you got my point? Yeah, please. Yes. RMS error. That is root mean square. Yes, yeah, I will show you, or I will demonstrate you during the practical session. Okay, so it will be clear during the practical session. So, but you must know the logic. That's why I am explaining that you must know the logic and the information of the. So, suppose if your error greater than the pixel value, and if you generate some product, then the product will be exact position in the ground, in reference to the ground position. Is it possible? It is not possible, and that's why we are trying to keep the error value half of the pixel. This is the whole and sole concept of the orthorectification. Orthorectification means we have a data of satellite data that is look like in a flat surface, and we have a DEM data, and now we have to generate a product using the information of the DEM data, that is the Z value, and the satellite imageries value, that is XY location and the DN value. So we can superimposing the DN value of the XY location in the Z value over the Z value. So that is the whole and sole concept of the orthorectification. So if you have any kind of scanned maps, air photographs, multispectral imagery, vector coverage, then we all need to, this need to be corrected or geometrically, atmospherically, and the radiometric correction should be done. Here I want to, one thing I want to mention, that if you download the data from USGS, Earth Explorer and the Sentinel-2 data, you can see there will be some level of the data. Level 1 data, level 2 data, level 3 data, and this labeling have some specific information. If you go for the level 1 data, then level 1 data is not geometrically corrected. Okay, if you go for the level 2 data, then level 2 data is geometrically corrected, and the atmospheric correction is there. So we don't need to go for the this process, and we don't need to replicate this process again during the data processing. So although these data are represent there, but for the some purpose, maybe you will not able to getting some you need a data of a temporal resolution like monthly temporal. Okay, that is you need the data January, February, March, April, May, June, and this time you can see that the for the March month there is no level 2 data is available in the site, and that time you have to go for the level 1 data, and you have to produce or convert this level 1 data to the level 2 data, so that you can continue your project work and the developing purpose. So we should have a short break of 30 to 35 minutes, then we will come to the image enhancement and error correction. Here? No. ADAS imaging is very sophisticated software, and for the developing for the only for the business purpose. So somebody is not coming from the background of coding language, so they can also use our product for their purpose. We have some special model.
Cannot somehow we can get access of their codes?
Yeah, you can.
Available.
Yeah. And for your information, I want to give one information that the Google Earth Engine, जिसमें हम लोग अभी जो ऑनलाइन डेटा एनालिसिस करता है, मतलब कि ये लिख के पाइथन कोडिंग करके इसके, वो अभी हेक्सागन हम लोग खरीद लिए, ठीक है। सो इन कमिंग डेज वो भी हमारे इस प्लेटफॉर्म के साथ हम लोग जोड़ देंगे ताकि आप यहाँ से डायरेक्ट उस चीज़ को कर सकते हैं। जलेर बोतल हो गया। So you have Morton 4.
Type of algorithm.
Yeah. There is, you can googling it on it. Yeah, you can identify. Morton 4 means ki moderate resolution atmospheric correction. So there is some algorithm that is known as the Morton 4, Morton 3. So currently we are using the Morton 4 techniques.
Okay, I just want to ask you one question. In laptop we have some spectral image.
Yeah.
Okay, and its original spectrum is like this.
Yes.
And due to scattering in atmosphere, we have some distorted spectra, like say like this type of spectra.
Yeah, that's why we are doing the atmospheric correction.
Yeah.
Na?
So means what type of technique you are using to remove this distortions?
Morton 4.
Bottom 4. So this is basically a code,
Yeah.
right?
Algorithm.
So
Which are
what
doing
the
the
direction
transformation regarding the atmosphere and the different type of angle of view. Okay, this type of information is being used for this running this algorithm. To run this.
I was doing some project, so this is the main problem.
Okay, so suppose here we are using the multispectral data, but somebody is telling in the morning that she is telling that she has seen that there is also the hyperspectral data. So do you have any knowledge about the hyperspectral data, the hyperspectral remote sensing? What is multispectral remote sensing, and what is the panchromatic? Okay, somebody have from the remote sensing background? Please raise your hand. Who are they? You. What is your name? Please sit. Okay. So you are from the remote sensing background. You are doing MSc? Okay. From where? Okay. So you might be knowing about the remote sensing system, and any others? You are also. You both two, no? You are three. Okay. So you have some knowledge about the multispectral, hyperspectral, and panchromatic data. So can you tell me in one or single in a summary, in a brief information, what is the panchromatic data? So your colleague will understand that your. Okay, no issue. So panchromatic always is a single band information. Single band means key data will be collected in a broader spectrum region, but representation of the data will be in a single band. So if you go for the Landsat thematic mapper, there will be one band, that is the panchromatic band. And again, if you go for the Cartosat, this also a panchromatic imagery. Panchromatic means the imagery is being this information is all information is being represented in black and white format. So in a total brightness black and white. And multispectral means there will be same ground view will be identified using different type of band information. It can be a blue band, it can be a green band, it can be a red band. So infrared band. So when you have the information of the same area in a different spectral region in a single band, different band using, that is known as the multispectral. Okay. And multispectral, when the band number is exceeding, that may be hundreds, that may be 155, 242. So that time we are telling that this is the hyperspectral data. So how many types of resolution are there in a remote sensing system? 4 type of resolution are there: spatial, spectral, radiometric, and temporal. So I am done the first session, and now the break is for 5 minutes. But for the left side, they are not giving some response during my presentation or the lecture. So do you have any problem about my lecture, and you are somehow you are not able to getting my points? Or yeah, otherwise smart people, and the you can use the just opposite of this one. So guys, if you have any problem, you can directly ask me. Okay. So we So shall we start? So now our next session is all about the image processing, that will cover the image registration, image enhancement. We already have some discussion about image registration, georectification and georeferencing, and image registration is same, but image registration is not limited to this georeferencing, because suppose you want to go for the change detection of some satellite data over a time period of 5 years, 4 years or per months. So this time you have some satellite image after and before. Okay, it might be taken in 2008 and then second satellite image is taken over 2009, and somebody is telling you please generate a map in between 2008 using these two imageries, and where you can highlight the changes from 2008 to 2009. So this time we need, I am just giving one example, it is not another key example, one of the key example, but it may be used for the other purpose also. I am just giving one example. So during this period we have to check each and every features of the two satellite data is matching, although both satellite data is given some georeferencing and having some projection for the overlapping the image. Okay, but we have to check whether these features are matching, and then if not matching, then we have to go for the image registration, and again we have to done the georeferencing and whatever the process we are doing. So ADAS Imagine, here I want to mention ADAS Imagine, for this purpose ADAS Imagine have automatic auto sync. They are just give your input of the two images, ADAS Imagine will do the rest work. You don't need to go for the manually giving the point and identifying the features from two images and matching and ultimately run the algorithm. We have these tools, you just giving input, give inputs of your two georeferenced data, and ADAS Imagine automatically give you the output, and that will be matched to each other. So image registration basically we are doing for image to image registration, and another is image to map. Image to image means you have two type of satellite data. I am already discussed that you want to change detection, that time we will go for the image to image registration. Image to map rectification means suppose you have a satellite data or you have a toposheet map that is georeferenced, but you have another satellite data or that is another toposheet map that is not georeferenced. So based on the one map I have to input or giving the georeference of the first map to the second one, that time we will go for the image to map rectification. So basically registration or rectification process involves relating ground control points, pixel coordinates with precise geometric correction. Why we here use the precise? Because previously I am telling that there will be some error, root means error. So suppose he is doing one registration of the one image and you will performing the another image. So based on your manual ability, mental ability, there will be some error. Whatever the accuracy you will gain, she will not able to maintain this accuracy. So there will also be some error, and that's why we have some automatic tool your image and your image, I will give the input of both image, and ADAS image will develop another product that will match either to you or to her. So, basic purpose is develop accurate data, direction and distance measurement, and accurate geometric rectification. For this purpose only, whenever you need the accurate data, direction and distance measurement, you need to accurate to geometric rectification is required for this data. Now, this is the practical example. You can see there is a topo sheet map, which the map orientation is in the eastern and western direction, but actually the this side should be in the upper direction. That will always, we are in the top side is giving in the north direction, and left side and right side, this side for the eastern direction and this side western, and the base is southern part. So, you can say that, see there, after processing using the ADAS image in geometric correction process, we have generated a geometrically corrected map. So, now you can see that when we clicked on this map, you cannot find this type of information. After geometric correction, we have giving them some point, GCB's points, and then telling that you should perform this or use this GCB point to process the image for geometric correction, that will in the geographic projection and WGS 84 datum. And now you can see that the latitudinal and longitudinal value is coming. You getting my points? You did this, so you have in ArcGIS. No issue, the process is same. This is very standard process. Now I am coming to the image enhancement. Now we have done the image geo-rectification, error correction, everything, but every error is eliminated. Now we will go for the image enhancement. Why we will do this image enhancement perform? Why we will do perform the image enhancement? Yes, exactly. So आप लोग अगर बीच बीच में एक दो वर्ड्स बोल देंगे ना, मुझे उसमें क्या होगा, मुझे और अच्छा लगेगा कि हाँ आप लोग समझ रहे हो चीज़ों को, है ना. तो हम लोग क्या करेंगे, इमेज का जो इम्प्रूवमेंट करने के लिए हम लोग इमेज एनहांसमेंट करेंगे. अभी तो करेक्शन सारे हो गया, अब तो कुछ करना नहीं है. तो अभी हमने बैंड स्ट्रिपिंग जो था वो भी करेक्ट कर लिए, वहाँ पे जो पीरियोडिक लाइंस था वो भी करेक्शन कर लिए, बट फिर भी वहाँ पे क्या होगा, कुछ जो ग्राउंड फीचर्स है, ग्राउंड फीचर्स क्या है कि वो काफ़ी डाइवर्स होता है ना. डाइवर्स मीन्स कि काफ़ी एनरिच्ड होता है. हम लोग कभी एक, अब जो सैटेलाइट इमेजरी हम लोग क्यों लेते हैं सैटेलाइट इमेजरी, कोई सैटेलाइट इमेजरी हम क्यों लेंगे, कुछ कारण है. क्योंकि हम मैनुअल कैमरे से एक फोटो लेंगे तो ओनली इस एरिया का आएगा, बट सैटेलाइट इमेजरी क्या करेंगे, एट ए टाइम आपको एक ग्राउंड शॉट जो होगा उसका काफ़ी लंबा होगा और काफ़ी लार्ज एरिया में हम लोग एनालिसिस कर सकते हैं. तो आपको कोई बोलेगा कि हमें गुवाहाटी जो सिटी है इसका एक मैप जनरेट करना है, वो मैप होगा लैंड यूज लैंड कवर मैप. तो आपको एक छोटा एरिया दे दिया जाएगा, आप उसको कहा जाएगा कि आप मैनुअली आइडेंटिफाई करो, उसमें काफ़ी टाइम लग जाएगा. बट आपके पास सैटेलाइट इमेजरी है और इस ग्राउंड नॉलेज है कि इस फीचर्स यहाँ पे ये है. जो हमारा गुवाहाटी सिटी है इसका नॉर्दर्न पार्ट में हमेशा ये कि नया नया बिल्डिंग बन रहा है, तो ये बिल्डिंग एरिया ही होगा. इसके साउदर्न पार्ट में क्या है, थोड़ा सा मतलब कि फॉरेस्ट्री है, इधर क्या होगा, रिवर होगा. तो इस टाइम ये नॉलेज है आपको, ग्राउंड नॉलेज. जब हम एक सैटेलाइट इमेज दे देंगे तो आप इजीली उसको एक क्या करेंगे, जब सॉफ्टवेयर में करेंगे ना, वहाँ पे हम लोग तो ये आइडेंटिफाई कर लिया. सॉफ्टवेयर में जब करेंगे उसको, सॉफ्टवेयर को उस चीज़ को बोलने के लिए क्या होगा, उस पिक्सल को आइडेंटिफाई करके देना होगा. सॉफ्टवेयर को बोलना होगा कि आपको जो हम इमेजरी दिए है इसमें ये पिक्सल वेजिटेशन का है, ये पिक्सल इसका है. सो ओके, ये कल डिस्कस करेंगे, ठीक है। इसके ऊपर मेरा एक सेशन ही है, ये कल डिस्कस करेंगे डिटेल्स में। तो इसीलिए सॉफ्टवेयर इमेज, हमारा जो सैटेलाइट इमेजरी यूज करने का और एक पर्पस ये भी है, एट ए टाइम हम लोग एक सिनेप्टिक एरिया का व्यू रहता है जिसमें कि हम लोग एक सेम फॉर्मेट में सेम एक्यूरेसी में एक अच्छा प्रोडक्ट डेवलप कर सको। ये एक हमारा पर्पस है सैटेलाइट इमेज यूज करने का। इतना सारे पर्पस के साथ ये भी एक एडिशनल पॉइंट है। ये छोटा छोटा क्वेश्चन जो है ना सत्यम जी, जब आपको रिक्रूटमेंट करेंगे ना प्रोजेक्ट में, तब इन्होंने पूछेंगे कि आप बताइए सैटेलाइट इमेजरी क्यों यूज करेंगे। सो फॉर दिस पर्पस वी हैव सम टेक्निक्स like contrast stitching, using histogram match equalization, density slicing, edge enhancement and spatial filtering. These are the common techniques we will be using for the image enhancement. Okay, so basically in summary you can say image enhancement methods are applied separately to, and another thing I want to forget to mention here, this technique are using for each band of a multispectral image. I already explained you what is the multispectral image. So multispectral image having some bands and panchromatic only single band information, but in a broader scale of the spectrum region. जब मल्टीस्पेक्ट्रल में आएंगे वहां पे इंफॉर्मेशन क्या होगा, 0.4 से लेकर 0.5 ब्लू बैंड में ही इंफॉर्मेशन कलेक्ट होगा, एक सिंगल लेयर हो गया। फिर ग्रीन बैंड में एक होगा, रेड बैंड में एक होगा। बट पैनकोमेटिक में क्या करेगा, वो 0.4 से लेकर 0.7 तक इतना एक बना देंगे, उसी में इंफॉर्मेशन कलेक्शन होगा। मतलब कि हमेशा पैनकोमेटिक में सिंगल बैंड इंफॉर्मेशन होगा, बट ब्रॉडर एरिया में होगा। स्पेक्ट्रम जो हम ये रीजन यूज करेंगे वो होगा क्या, ब्रॉडर होगा। बट जब आप हाइपर स्पेक्ट्रल में चले जाएंगे वो क्या होगा, वो ब्लू बैंड को भी आप डिवाइड कर देंगे। यहाँ पे जैसे कि 1 माइक्रोमीटर का इंटरवल था मल्टीस्पेक्ट्रल में, वहां पे क्या होगा, वो 15 मीटर का हो जाएगा। इफ यू गो फॉर द UO1 hyperspectral data, you can find there will be some 242 bands. Just a minute. Hello.
From the students, nobody has any problem in understanding in the Hindi, right? We are not requesting you to speak in Hindi, but at least you understand, right? Yeah. Okay. Thank you.
Anytime. So it will be, I will be happy to answer your question, because if the question is not coming from you, that's mean otherwise you are not understanding the things, or you are the expert over than me. So now I am coming to the contrast enhancement by the histogram stretch. So somebody will ask me that, sir, you have given two imagery, that is understandable, that very much understood that you have given two imagery, one is before and one after, and the some values or the visualization has been changed. But thing is that these two images are the same image and giving some spectral information, radiometric information जो है उसमें थोड़ा सा changes किया गया, but this image is very important, very purposefully. Why? You can see here, this is the original image, the histogram value, and I am telling that the DN numbers, already I mentioned you, or the DN, you can see that the DN numbers is coming in between just 36 to somewhere in 70. So the histogram in between here. Now if we stretch this part to the computer having the power only show you 0 to 256 means the 8-bit data. Am I right? So if you stretch this histogram value and feed this histogram value to this, so the image the limitation of the identification between the in between the features, that will be increased and give you some enriched information. So you can see there, after histogram equalization, some parts of the images is very highlighted, which is not possible here. So this region basically is a urban region, these are the water bodies and these are some vegetation parts. So you can see that after histogram equalization, here you will be able to identify this feature very easily, and some linear features road. So for this purpose, if you identify the roads and the some other features, then you have to go for this type of image enhancement technique, so that you can extract or identify the features at the maximum level. So no information should be eliminated during your process. Am I right? Let us imagine whatever the samples or whatever the things we are presenting here, we are using the ADAS Imagine. We have different types of other software also, ER Mapper, photogrammetry tools, but ADAS Imagine is our main platform, and others add-on tools is coming to the ADAS Imagine only. So first you have, or you should purchase the ADAS Imagine, you should have proper license, and then you can install each and every add-on tools and modules.
Sir, in Saga also there is a one means image enhancement.
Yeah, you are
is
right.
there.
Saga means you are telling about the QGIS, and when you installing the QGIS, that will give you Saga and different of others add-on tools and softwares are there. So that this application also
same sir, with the AirDos and Saga, it is same.
same process is there, but problem is that I already mentioned you that ADAS Imagine is a very standard and business software. But when you doing the things using the QGIS might be having some many features and many things will be there, and these are free of cost. But when somebody is giving you some free of cost, you don't know there will be some limitation also. मैं आपको कुछ अगर फ्री में दे रहा हूँ तो कुछ लिमिटेशन उसमें होगा, क्योंकि आप उस प्रोडक्ट को पूरा यूज नहीं कर पाएंगे. तो QGIS के साथ प्रॉब्लम क्या है, उसमें जब भी आप मतलब कि अभी आप सेंटिनल डेटा एक डाउनलोड कीजिए या लैंडसेट कीजिए, उसमें क्या होगा, एक डेटा जो है ना 700-800 MB के आसपास होगा. तो आपका ये डेटा वॉल्यूम जैसे बढ़ते जाएगा और आप एक बड़ा एरिया के ऊपर स्टडी कर रहे हैं, उसको मार्च करने जाएंगे, ठीक है, उस टाइम में QGIS बोलेंगे कि कुछ देर बाद बोलेंगे भैया यहाँ तक तो ठीक था, इसके आगे हम नहीं कर पाएंगे, आप एरर देते रहेगा. उस टाइम में आप क्या करेंगे, आपका प्रोजेक्ट वहीं पे रुक गया. तो दैट्स व्हाई people are not doing the things using the QGIS. They should have some softwares like ADAS Imagine, ER Mapper, other softwares also available. ठीक है, तो ये सॉफ्टवेयर में क्या होगा, आपको जब भी कुछ प्रॉब्लम हुआ आप हमें फ़ोन लगाएंगे कि भैया आप तो प्रोडक्ट बेच के चले गए, आप आइए, ये काम नहीं कर रहा है, तो तुरंत हम आपके पास आएंगे, आपको सॉल्यूशन देके सॉल्व करके हम यहाँ से जाएंगे. ये है कि स्टैंडर्ड प्रैक्टिस है, एक बिजनेस प्रैक्टिस है, एक बिजनेस प्रोडक्ट है. बट QGIS में प्रॉब्लम होगा तो आप कहाँ से करेंगे, आपको उसका इसमें लिखना होगा, जो उनका जो कम्युनिटी होगा, कम्युनिटी में लिखेंगे तो हमारे जैसा या कोई स्टूडेंट आपके जैसा या कोई भी एक्सपीरियंस पर्सन उसके पास अगर टाइम है देख लिया तो छोटा सा एक लाइन लिख के भेज देगा. आप उसके पीछे 6 मंथ क्या है कि खींचते रहो उसमें, कि आप उसके पीछे पूछो कि भैया आप जो लिखे इसका मीनिंग क्या है, कैसे होगा, आप कैसे करेंगे. तो ये क्योंकि वी आर ऑल अल्टीमेटली वी हैव सम पर्पस एंड वी हैव टू कंप्लीट दिस पर्पस इन ए टाइम लाइन. ठीक है, तो टाइम वेरी इंपॉर्टेंट. So here you can think that the simply you can see here. So we have the imagery of this level of the pixel values are coming in between this some range, and we just stretch this length to this 0 to 255 वैल्यू. सो इमेज का जो फीचर्स का जो आइडेंटिफिकेशन या जो पावर है वो इंक्रीज हो गया इससे. दैट इज नोन एज द हिस्टोग्राम स्ट्रेचिंग. एंड यूजिंग द सेम टेक्निक वी हैव द हिस्टोग्राम मैचिंग ऑल्सो. सपोज यू हैव ए सैटेलाइट डेटा and that is taken over on 2008, and when you go for the 2009 you can see that some radiometric disbalance is there. So we have to match this disbalance, we have to correct this disbalance, otherwise we cannot perform the change detection. Maybe some part will be brighter and in the second image some part will be darker. So when computer will perform the change detection, they will properly it will unable to understand or unable to extract the information properly. That's why we need to the histogram matching. We have to perform the histogram matching. Edge enhancement. Here this technique is very important. This is the water body. Can you see that some pixel is there that might be due to the shallow water or some sand part is there, or might be the moisture level is higher. Water is not represent there but moisture in the soil, and that's why it's looking. But when you using this image enhancement technique, using the edge enhancement technique, then you can see that the edge are looking very clearly. So now you can फटाफट आप डिजिटाइज कर लीजिए इसको, है ना. यहाँ पे क्या है, एरर होने का चांस जो है वो बहुत मिनिमाइज हो जाता है. बट वन थिंग यू शुड रिमेंबर दैट in remote sensing and in GIS we are not able to give 100% accuracy. We are not able to give some 100% accuracy. We are somewhere in behind 95%, 98%, 80%. So error will be there, but we are trying to improve ourselves, and our GIS teams are doing same for towards the 100, but it is not possible giving the 100%. So everything आपको एक कॉन्सेप्ट हो जाता है जनरल नॉर्मल पीपल का कि जीआईएस मीन्स कि हम जो कर रहा है वो एग्जैक्ट ये हो रहा है. आप अगर जीपीएस लेके डेटा कलेक्ट करने जा रहा है और उसको मैप में प्लॉट करेंगे तो वो भी एग्जैक्ट नहीं होता है. जीपीएस में भी कुछ एरर होता है. वो किसी में 3 सेंटीमीटर होता है, किसी में 10 सेंटीमीटर होता है, तो उसका वर्टिकल हॉरिजॉन्टल एरर दिया रहता है. सो डू यू हैव यूज्ड द जीपीएस डिवाइस? Somebody have knowledge about the GPS device? How many type of GPS devices is there? Okay.
So this mobile GPS we have used.
No. Suppose if somebody from the non-remote sensing background.
For this field data collection and GPS things also, we have kept a module.
Okay.
But you clarify them.
Yeah, definitely. Now, just a simple question, because some students are coming from the remote sensing background, so I expect some enriched knowledge from them in compared to the others background peoples. Okay. So actually क्या है कि आप जब मोबाइल डेटा यूज करते हैं तो हर मोबाइल का अलग अलग ये होता है. ठीक है. डेफिनेटली कि आपके अगर कुछ प्रोजेक्ट कर रहे हो या आपके पास फंडिंग कम है तो उस टाइम में हम लोग उसको कंसिडर करते हैं. बट वी विल ट्राई टू improve our accuracy. Although the data is collecting using the mobile or other device, but in some ways we are trying to improve the accuracy. So after pre-collection, post-collection, we have some models, we have to go through some models या statistical analysis to improve the result. तो ये अभी पाठ नहीं है, इसमें ज़्यादा मैं टाइम वेस्ट नहीं करूँगा. ठीक है. तो आपका एक सेशन है, उन्होंने बताया कि उसमें आप लोग सीखेंगे. तो बेसिकली ये क्वेश्चन मैं सेकेंड हाफ में आप पूछूंगा कि जीपीएस क्या है. मैं एक्सपेक्ट करता हूँ आप सेकेंड हाफ में बताएंगे. ठीक है. क्योंकि ये आप जब जीपीएस यूज करते हैं इसका क्लासिफिकेशन समझना इसीलिए ज़रूरी है क्योंकि जीपीएस क्या है कि हर डिवाइस के ऊपर उसका एक्यूरेसी चेंज होता है. जीपीएस व्हाट इज द फुल फॉर्म ऑफ जीपीएस? ग्लोबल पोजिशनिंग सिस्टम. सो व्हाट इज द कॉन्सेप्ट एक्चुअली? different agencies are giving different type of GPS constellation satellite system. If you go for the US based, there is 24 satellite in the constellation, and in our India there are 7 satellite is there for the Indian region only. We are very clever. We are not going for the global region. We are just capturing in our region. It may be to improve our security, and basically we are doing these things for the defense purpose only. Now another thing is that when we will go for the practical session, there is the another important resolution march. I am telling that you have the some type of data. Now here is the basic example of a QuickBird. Do you have listened about the QuickBird satellite data? QuickBird is a satellite sensor. So QuickBird is very high resolution satellite, you can say. This panchromatic imagery, whatever I am telling now, you can look over here that this is the example of an panchromatic imagery, and the spatial resolution and the pixel size is 0.6, mean 60 centimeter. So can you imagine something in between the 60 centimeter? This satellite is able to differentiate in between these features. But here is another imagery which is multispectral, but from the same platform, the sensor is different. Multispectral is collecting 2.4 meter pixel size, 2.4 meter. So whatever the ground features is less than 2.4 meter, this satellite is not able to identify these ground features. Are you getting my points? सपोज हम लोग हाई रेजोल्यूशन सैटेलाइट डेटा क्यों यूज करेंगे, पहले ये बताइए, बेसिक फंडा. एक हाई रेजोल्यूशन सैटेलाइट डेटा को हम लोग क्यों यूज करेंगे, कुछ तो कारण होगा. यस, if you go for the identification of different type of household in a city, then आपको कोई एक लीस्ट 3 का डेटा दे दिया, उसमें एक एक घर को दिखेगा, नहीं दिखेगा, क्योंकि लीस्ट 3 का रेजोल्यूशन क्या है, नो 23.5 मीटर. एम आई राइट? 23.5 मीटर. सो फर्स्ट ऑफ ऑल मैं आप सभी लोगों को बोलूँगा कि यू शुड go for the how many satellites are there and what type of information they are collecting, what is the specification of this satellite. You must have knowledge about this satellite data. Then somebody, if some entrepreneur is coming to you, सर मुझे एक सॉल्यूशन बताइए कि मुझे फॉरेस्ट्री के ऊपर काम करना है और उसको मैपिंग करना है, उसमें जो डिफरेंट टाइप ऑफ फॉरेस्ट है उसको मैप करना है. अच्छा अच्छा, ये क्या करेंगे ना, कल का जो मेरा ये है क्लासिफिकेशन, वो क्लासिफिकेशन में ही इस चीज को एक्सप्लेन करें. वो कि 15 मिनट्स का सेशन रखूंगा, जिसमें आप लोगों से ये एक्सपेक्ट करूंगा कि हमारे जितने भी प्लेटफॉर्म्स है उसमें किस तरह का डेटा है और उस डेटा का रेजोल्यूशन क्या है. हम उसमें से क्या क्या क्वेश्चन पूछेंगे कि 4 डिफरेंट टाइप ऑफ रेजोल्यूशन इज देयर इन रिमोट सेंसिंग डेटा. व्हाट इज दैट? फर्स्ट इज स्पेशियल रेजोल्यूशन, स्पेक्ट्रल रेजोल्यूशन, एंड देन टेम्पोरल रेजोल्यूशन, एंड अनदर इज रेडियोमेट्रिक रेजोल्यूशन. वेरी गुड. So what is the importance of radiometric resolution? रेडियोमेट्रिक रेजोल्यूशन मीन्स कि वो आपको होता है ना, कोई बोलता है कि बीट, ये 8 बीट डेटा है, ये 16 बीट डेटा है, ये 32 बीट है, 64 बीट है, कंप्यूटर में आप करते हैं ना, तो व्हाट डज इट मीन 32 बीट 64 बीट, ये कहने का क्या मतलब है? प्लीज प्लीज स्पीक. हाँ, रेडिएशन जो है उसमें क्या है कि ये जो कलर रेंज हम देख रहे हैं ना, मान लीजिए ये, हाँ एग्जैक्टली ग्रे लेवल्स, ये दोनों जो है एक ही कलर का ये टी शर्ट है, ठीक है, ग्रीन कलर का ही है, बट इफ यू वांट टू स्प्लिट अप दिस ग्रीन कलर इन डिफरेंट मोर कलर्स and color shadow, then what we will do, the bit resolution should be increased, so we will be able to different shadow under this green also, ठीक है। अगर ग्राउंड में दो आपको वेजिटेशन है, फॉरेस्ट्री में आप जाएंगे या तो ये एक एग्रीकल्चर फील्ड में गए, आपको वो भी एक ये हो गया ग्रासलैंड हो गया और उसके साइड में ही सेम और एक ग्रासलैंड है, but our objective is that we have to identify the different growth levels of this grass. तो आप एक सैटेलाइट डेटा यूज किया है जिसमें कि रेडियोमेट्रिक एवल्यूएशन 8 बिट है और एक में 32 बिट्स है, तो बेसिकली क्या होगा, जो 32 बिट्स है ना वो क्या है, इसका जो डिफरेंट टाइप ऑफ कलर शेडो है ना वो आइडेंटिफाई करने का ऑप्शन आपको ज़्यादा देगा, और जिसमें 8 बिट्स है वो आपको कम देगा। तो 32 बिट्स वहाँ पे हेल्पफुल होगा क्योंकि उसका जो दोनों का आप बोलेंगे कि ये 7 दिन पहले हुआ था इसलिए इसका ग्रोथ रेट थोड़ा सा हायर है, इसका कम है, अदरवाइज वी कैन गो फॉर ऑल्सो NDVI, बट फॉर द विजुअल इंटरप्रिटेशन इज वेरी इंपॉर्टेंट, वी कैन डू इट विजुअली अदरवाइज डिजिटली, बट बोथ आर इम्पॉर्टेंट, ठीक है। तो विजुअल इंटरप्रिटेशन के लिए आपको, अदरवाइज हम तो कंप्यूटर में जो बताएंगे वो कर देंगे, ठीक है।
रेडियोमेट्रिक का सबसे बेस्ट एग्जांपल है लड़कियों का, लड़कों का है बेसिकली जो है, हम एक साइड पर हमारे लिए सब ब्लू है और पिंक है, बट लड़कियों को देखो उसके लिए बहुत सारे हैं ऑप्शंस,
एग्जैक्टली
बेसिकली ये फंडा है आपको रेडियोमेट्री समझने का।
सो दिस इज वेरी स्टैंडर्ड एग्जाम्पल, एक्चुअली इस तरह का एग्जाम्पल होगा तो आपको माइंड में घूमते रहेगा और इजीली आप कैच करेंगे, ठीक है। तो हम ज़्यादा इसमें एक्सप्लेन नहीं करेंगे क्योंकि हमें प्रैक्टिकल सेशन भी करना होगा, ठीक है। तो ये है कि रेडियोमेट्रिक रेजोल्यूशन, तो यहाँ पे एक तो so now we have two types of data, one is the panchromatic and another is the multispectral. You can see and you can analyze these two type of imagery. You can see that in the panchromatic band there are some vehicle is there, it is clearly looking here, okay, clearly you can, this can be identifiable in this image, but here can you see some vehicle is there also, but are you able to identify this? No, because the resolution is 2.40 and here the resolution is pixel size is 0.60, so whatever the information, these are less than 2.4 meter, this has mixed pixel basically, so information has been merged. एक 6 सेंटीमीटर ये है, इसको डिटेक्ट करने के लिए क्या सेंसर चाहिए हमें, सेंसर का स्पेशल रेजोल्यूशन क्या होना चाहिए, ये हमारा 6 सेंटीमीटर का ऑब्जेक्ट है और ये हॉरिजॉन्टली ऐसे है, ठीक है। इसको हमको डिटेक्ट करने के लिए किस तरह, कौन सा स्पेशल रेजोल्यूशन का ये चाहिए, ऑब्वियसली 0 लेस देन 6 सेंटीमीटर का होना चाहिए, तभी हम इसको मेजर कर पाएंगे ना। अगर ये हमारा हम 0.7 सेंटीमीटर का रख देंगे तो ये तो क्या होगा, पिक्सल के अंदर घुस जाएगा, तो इसके अंदर दो अगर इस तरह का रिमोट होगा तो दो को मैं आइडेंटिफाई नहीं कर पाऊंगा। तो दैट इज द मेन basic concept of the spatial resolution. If you increase the spatial resolution, so your power of image analysis will be increased. So different type of object and features you can identify the broadest level, but in case of low resolution data you cannot do this. But suppose you have a two type of data, one is very low resolution and another is very high resolution, and based on high resolution you will say my high resolution data is the one of the very good resource, but low resolution data is not, so you can throw out it. It is not like that. If you go for if your study area, I already given an example, if you go for the mapping for whole India, then you cannot do this using the 0.6 centimeter data, you have to go for the least 3, because that will give you some, the process is very time consuming, okay. So one by one image you will go process, and then after that finally you will able to get generate some. So there will, when the process are increased, so the error will also be increased. But thing is that nowadays we have the different type of solution and technically we improved that level, but we can also use this type of high resolution data for the classification at a broad region, in a broad region. Now using the ADAS imagine pan sharpening method resolution, we have taken the multispectral information from this data and we have taken the spatial resolution of this data and we merge this data to generate a new product. Now we can see that this data have no color value here, but here you can see that the merge value have some radiometric and spectral information, both are there. So in this way we can improve the imagery for the data analysis. So that is known as the pan sharpening और resolution merge. दो जो resolution है उसको हम लोग merge कर दिए. Now I am coming to the image filtering. What is image filtering? Basically in image there are some spatial frequency. So defined is a number of change in the brighter value per unit distance for any particular part of an image. If you take an image of a arid region or semi-arid region, there will be in an image, all image will be brighter because there will be only sand. But if you go for a Guwahati city, there will be vegetation, there will be river line, road line, urban. So when the earth feature, options for the earth features is increased, the frequency of spatial frequency also increase. So in a image you can see that, you can notice that in when you moving otherwise horizontally or vertically in a shorter distance the spatial frequency is changing. But if you taken a semi-arid region or a oceanographic image, ocean image, then you can see the image is capturing over the ocean, so all part in the ocean. So the radiation value is not much changed in between the pixel. Are you getting my points? अगर आपके पास दो सैटेलाइट इमेज आ रही है, ठीक है, एक में हम एरिड रीजन मीन्स कि जहाँ पे रेत होगा वहाँ का फोटो ली है और दूसरा है कि एक सिटी का ली है. रेत मीन्स कि सारे पिक्चर में रेत ही है, तो रेत मान वहाँ पे जो स्पेशल फ्रीक्वेंसी है, जो पिक्सल में जो डीएन वैल्यू जो रिफ्लेक्टेंस है वो ज़्यादा चेंज नहीं होगा. आप चाहे नॉर्थ में जाइए, ईस्ट में जाइए, सेंटर में आइए, पिक्चर का वो मोटा मोटी एक लेवल में रहेगा क्योंकि वो एक सिंगल एंटिटी का है ना. बट अब जब एक इमेज है जहाँ पे आपको कि वेजिटेशन भी है, रोड भी है, तो वहाँ पे क्या होगा, इमेज का ब्राइटनेस मतलब थोड़ा सा आप मूव करेंगे नॉर्थ की तरफ या वर्टिकली हॉरिजॉन्टली किसी भी तरफ आप मूव करेंगे तो वहाँ पे क्या होगा कि चेंजिंग जो है वो रिगोरसली होते रहेगा. तो इसीलिए क्या होगा कि वो स्पेशल फिल्टरिंग, तो आपको क्या करना होगा, शायद हमें एक जगह में मिल गया कुछ ब्राइट पार्ट्स मीन कि कुछ आप सैटेलाइट इमेज लेंगे तो उसका छत दिख गया, वो ज़्यादा ब्राइटर वैल्यू में होगा, और उसी के सामने कुछ सैंड नहीं, कुछ एरिया है जो डार्कर में आया है. डार्कर मीन्स कि कुछ वहाँ पे ऐसे चीज़ है जो कि एब्जॉर्ब कर लिया लाइट को. तो अब क्या है, एक ज़्यादा हाई फ्रीक्वेंसी में होगा और एक लो फ्रीक्वेंसी में होगा. तो उसमें क्या है कि इमेज में उस चीज़ को हमको आइडेंटिफाई करने में क्या होगा, पूरा इमेज ऐसे स्पेशल फ्रीक्वेंसी में होगा तो हमें प्रॉब्लम होता है कुछ फीचर्स को आइडेंटिफाई करने में, क्योंकि ड्यू टू दिस ब्राइटर फीचर्स is the neighbors of these features cannot be determined, and that's why we are performing some filters, special filters. One is the low pass filter and another is the high pass filter. So basically we are using the low pass filter for smooth out the image noise or reduce the spikes in the data, and using the high pass filter, high frequency detail to enhance the sharpen linear features as road, fault, land, water, boundaries. So if somebody is coming from the geological background, so he wanted to use the high frequency because he have to identify the fault line. So suppose he has an image of the this type of geological information which carried out by the satellite imagery, and then he have to go for the high pass filters. So when we will go for the practical session, I will explain you how many type of high pass filter and the pixel selection, how do you select this information to identify the linear features for vertically, horizontally. Okay. Now this example will clear your understanding. Like that, here it is an image, you can see that these are the actually basically port region, it is a port region. So here some otherwise a ship or different type of ground features are there. So it's giving the values in the highest high number, or using the low pass filter we trying to matching this brightest value and the with the low frequency of the darker part. Okay. Now this low pass filter only giving you permission to pass the those pixel having the low number of DN value, that will be passes, and the higher values will be somehow that will be managed to match with the lower pixel value or the dark value. So now we can see that this brighter value is being here, this has been matched. Actually this is the based on salt and pepper, we have listened about salt and pepper. अगर पेपर के ऊपर कुछ न्यूज पेपर के ऊपर अगर सॉल्ट गिर जाएगा, वहाँ पे देखिए कैसा होता है, वो कैसे दिखाता है कि पेपर का कुछ पार्ट ब्राइटर हो गया, नीचे ये हो गया. तो उस टाइम में क्या करते हैं, कुछ प्रोसेस आप लाते हैं कि उसको मिनिमाइज करके वो पेपर को ऐसे, तो सेम टाइप पे ये प्रोसेस है जहाँ पे हम लोग की एक सैटेलाइट इमेज का विजिबिलिटी को इंक्रीज करते हैं. In the same way we are using the low pass filter. Here you can see that those having the highest number of reflectance value that has been passed through the high pass filter, but this has been minimized. So these features has been highlighted. So it will be easy to identify from the images. Now you can digitize or extract this information easily from the satellite data, and that is the main funda or for using the low pass or high pass filter. So high pass filter basically we are using to extract the road. You have a road network or anything linear network, that time you can perform the high pass filter. Not in the -1. That actually we are trying to represent that we minimize the transformation of this DN value, so that कि हम क्या करेंगे, इसके background में इसको highlight कर सकते हैं. So process is that high pass filter giving the जिसका reflectance value higher है उसी को pass करने का chance ये दे रहा है, और बाकी जो low है उसको वो रोक के जिसको analysis कर रहा है कि ये जा सकता है कि नहीं, उसको कुछ level तक ही जाके मतलब minimize कर रहा है, ताकि हमें यहाँ पे जो features है उसको हम identify कर सकें. Now I am coming to image transformation or manipulation. So we have done all the process, that is image registration, georectification, radiometric correction, atmospheric correction and image enhancement. Now our image is ready to generate some product. Here image transformation means in an image based on arithmetic, otherwise we will do it using the arithmetic operation. He is asking that what is the spatial model. Here again we can use the spatial model to convert the image information to a product information. Suppose, do you have listened about do you know the NDVI? NDVI. So what is the purpose of NDVI? We are calculating the NDVI to understand the vegetation growth or vegetation health. So that is the main purpose. There we are using some arithmetic calculation. Okay. So now my image is ready to develop some product using the processing and pre-processing method. And another is thing that resulting this image will have properties that make them more suited for a particular purpose than the original. So NDVI is a well known purpose, we know that, but something is not well explored, or something is we have a new project and then we want to identify the some features that is not previously identified and not developed any model for these features. So Using this part, you can develop some mathematical formula to convert the band information to a product information. So, why do we use the image transformation? Convert the raw satellite data information to a product information, we will basically use the image transformation. आपके पास कुछ सैटेलाइट डेटा है, आप तो करेक्शन कर लिए, क्या आपके सैटेलाइट डेटा हम रख देंगे उसको? रख देंगे उसको क्या? उस सैटेलाइट डेटा से हम तो कुछ इंफॉर्मेशन निकालेंगे ना, तो वो जो इंफॉर्मेशन, दैट मीन्स दैट सम यू आर जनरेटिंग सम प्रोडक्ट. सो उस प्रोडक्ट जनरेट करने के लिए हमें कुछ एरिथमेटिक फॉर्मूला जनरेट करना पड़ेगा, या तो बैंड 1 डिवाइडेड बाय बैंड 2, बैंड 1 मल्टीप्लाई टू बैंड 3, ऐसे करके कुछ हमें करना होगा, तभी जाके एक फीचर्स को हम आइडेंटिफाई करेंगे. अगर वाटर को हम आइडेंटिफाई करेंगे तो उसमें क्या करना होगा? नॉर्मलाइज डिफरेंस वाटर इंडेक्स कैलकुलेशन करना होगा. सो दैट इज द main these are the main points for transforming the or manipulating the image. So here we can manipulating or transforming the image in two ways. Somebody, I think that one of the standard practice is that principal component analysis, and another is that the manipulation, that is indices or band ratio calculation. So I am not coming in the details of principal component analysis. Actually, what it is doing, principal component analysis? Principal component analysis mean कि आपका जो डेटा का जो इंफॉर्मेशन है, suppose you have a 242 band information or 15 band information, is it possible to analyze or extracting all the band information from same from 15 bands at a time? Is it possible? It is not possible. तो यहाँ पे मैं एक सिंपल एग्जांपल दूंगा कि आप लोग यहाँ पे कितने लोग हैं? 17 लोग हैं, है ना? तो डिफरेंट बैकग्राउंड का है. हमें क्या है, एक रिमोट सेंसिंग का चाहिए, एक जियोलॉजी का चाहिए, एक एग्रीकल्चरल का चाहिए. तो एग्रीकल्चरल some peoples are from 10 people from agricultural, and some you are from some 10 people from remote sensing and 5 are from others. So यहाँ पे क्या करेंगे, एक स्टैंडर्ड प्रैक्टिस क्या है कि आपका 10 के अंदर अगर आप सेम इंफॉर्मेशन कैरी कर रहे हो तो हम 10 को नहीं रखेंगे. वहाँ पे क्या करेंगे, एक स्टैंडर्ड जो आपके ज़्यादा इंफॉर्मेशन हो उसको रखेंगे, जो ज़्यादा जानता है, जो हमारा मतलब इंटरव्यू होता है इसके थ्रू इवेलुएट करता है स्टूडेंट का या कोई भी पर्सन को, यहाँ ग्रुप से भी एक ही लेंगे. या तो अल्टीमेटली क्या है, सेम इंफॉर्मेशन, हम इंफॉर्मेशन में कुछ सप्रेस नहीं किया है, क्वालिटी सेम रहा, बट क्या है कि हम नंबर ऑफ पीपल्स को रिड्यूस कर दिए ताकि एक ही पीपल से हमें ये मिल जाएगा उसमें, क्योंकि 17 होगा तो हम कर नहीं पाएंगे, तो इसलिए 3. तो सेम प्रोसेस इज डूइंग प्रिंसिपल कंपोनेंट्स. सो सपोज यू हैव ए 15 or 20 bands, so it's performing this algorithm process to identify the information pixel wise. So those pixel having the rich information, it will take him, and otherwise it will release him to compress the data in a lowest volume. So now you can use this data for the classification purpose. So you don't need to go for the all bands at a time for the classification. You can run the principal component analysis, and then the data volume will be increased and your work capability will be, data volume will be decreased and work capability will be increased. So our third session for the day will be the manipulation, that is the indices or band ratio calculation. And before that, coming to this band ratio or indices calculation, I would like to give you some information about the remote sensing. Although you having the session last 2 days, so here you can see that each and every bands I am telling about the multispectral and hyperspectral and panchromatic. These you can see that blue, green, red, these are the all spectral region. If sensor is able to detect the information using the blue, then it is a blue band, and if it able to collecting the data using the green band, then the information are representing in the green band, like in this way, red, near infrared, short wave infrared, different type. But when we are using the computer having only 3 guns, that is red, green and blue. So whatever at a time we are able to transform the information only 3 bands. So otherwise you have to give the short wave infrared this band to you have to give input here, near infrared, and then the image visualization of the image will be changed. Here we are giving the true color, blue to blue, green to green, and red to red, and that's why you can see there is a true color composite, that is known as true color composite. So in the next slide you can see there will many example of this type of data. So this is the thematic, I think thematic 3 or 4, that time thematic mapper having 7 bands, and using 7 bands you can see that is the red, green and blue. This is also known as the FCC, false color composite. So somebody, can you tell me what is FCC? What is the main concept for producing the FCC? So please note down it, it will be for your tomorrow's task. I will ask you that. What is FCC and why we will use FCC for the remote sensing data analysis? Sorry? What is FCC? False color composite. And what are the use of FCC for remote sensing data analysis? So people from the remote sensing background, can you tell me what is FCC exactly? Yeah, that I know. That is the just you transform the word a letter to the words. Yeah, yeah.
Suppose for example forest area. So in forest area in FCC it will be red. So we are getting different types of color. So we can identify different types.
No, actually the purpose of FCC means ki what is FCC, you are telling what is FCC and how it is looking, the ground features, how it will be looking for the in the FCC. I don't want information about that. I want to know that why we will use the FCC. So FCC is the standard practice. Suppose you are sitting here in India and somebody is doing the same work in America and US and the European region. So the standard practice of representing any raw satellite data, that is the false color composite, that will help you to FCC means कि वहाँ पे जो आपको मेरा जो ग्राउंड फीचर्स है, सपोज कुछ डिफेंस एरिया है ना, तो हम उसको FCC इमेज इसीलिए देंगे कि वहाँ पे कुछ रेस्ट्रिक्टेड इमेज है, उसको हम अगर ट्रू कलर में देंगे तो उसको दिख जाएगा वो चीज़ें कि वो भाई ये तो मिलिट्री एरिया है ना, वहाँ पे क्या है कि हमारा इंफॉर्मेशन जो है वो डायरेक्टली इंटरप्रेट कर सकता है देख के। आप अगर मतलब कि आपका ये जो भी फेस अपीयरेंस है, मैं एक एक कलर दे के बोलूँगा इसका ये पार्ट ये है, ये पार्ट ये है, तो उसमें क्या होगा, आपका जो एक डिकोडिंग रह गया, उसमें हम डायरेक्टली आपका इंफॉर्मेशन को एक्सेस नहीं कर रहे हैं, हम एक एज्यूम कर रहे हैं कि ये होना चाहिए. सो FCC इज द स्टैंडर्ड प्रैक्टिस टू रिप्रेजेंटिंग द ग्राउंड फीचर्स वर्ल्ड वाइड. So if you take a screenshot of this FCC image and giving somebody in the USA, and he will also perform the land use land cover analysis, and you will also perform the land cover analysis. So using the red value, now you are explaining that using the red value you will be saying that this is the vegetation part, and the cyan color would be some what? No, some urban settlement or built up area. So in this way he will also say the same things. The thing is that we have normalized the thing for using the FCC data. Okay, so this is the basic or standard practice for the FCC data creation, that कि आपके पास कुछ डेटा है, आप किसी को भी भेजिए, चाहे वो रिमोट सेंसिंग का बंदा है या नॉन रिमोट सेंसिंग बंदा है, वो क्या करेंगे, वो FCC का जो रूल्स है उसके हिसाब से वो ग्राउंड फीचर्स को आइडेंटिफाई करके मैपिंग करके दे देंगे. लेकिन एक ट्रू कलर दे देंगे, वो क्या करेंगे, ये तो भाई वेजिटेशन है, हमें दिख रहा है क्लियरली, बट आप बोलेंगे कि नहीं भैया मैं उसके पास रहता हूँ, वो मेरा लोकल एरिया है, वो वेजिटेशन नहीं है, वहां पे सम ग्रास है। तो यहाँ पे एक कॉन्ट्रडिक्शन होगा ना, आप एक क्लासिफाई करके देंगे दूसरा मैप, वो एक क्लासिफाई करके देंगे। तो इसी के लिए हम लोग क्या करते हैं, एफसीसी जनरेट करते हैं। एफसीसी जनरेट करके अगर ऐसे एक ग्रुप में हमें एनालिसिस होता है तो उस टाइम हम लोग एफसीसी इमेज को ही देते हैं। बट फॉर आवर my purpose and improving the project accuracy, we will go for the different type of band visualization. So now you can see that using the different type of band information, you can generate the different type of first is the FCC image, which is representing the vegetation appeared in red and water appears navy or black colors, and in the true color you can say we are using 3 to 1, band number 3 to 1. So 3, what is 3? Suppose blue, green and red. So here near infrared is blue is giving in the blue, red is giving in the red and near infrared giving in the near infrared. That's why this is true color. कंप्यूटर में जो ब्लू, ग्रीन और रेड का जो गन है, कंप्यूटर एट ए टाइम वही समझेंगे। जो आप बैंड चाहे कुछ भी दे दीजिए कंप्यूटर, लेकिन वही तीनों गान में ही काम करेगा। वो एट ए टाइम 3 बैंड्स को ही शो करके एक आपको कलर इमेज देगा। और यहाँ पे देखिए बैंड 542 यूज जब करेंगे तब क्या है कि यहाँ पे कलर्स डू नॉट रिफ्लेक्ट द फीचर्स इन द नेचुरल कलर्स। हियर colors are not reflect in the natural colors, but roads may be red and vegetation may be green. This is also one type of FCC, but this FCC is using for the standard practice worldwide. And in the same way, if you want to some urban distinction and vegetation distinction, then you can go for the 543 thematic mapper का जो bands number है ना, you can go for the band combination of 5, 4 and 3. And if you want to only identify the urban region, then you can go for the 542. But thing is that currently we will not use the thematic mapper, so we don't have the 7 bands. We have the Landsat 9 now, and there in the MSS sensor there is only 4 bands, and that's why I am not giving the current example, because you have to explain your data using the multispectral data for increasing or improving your knowledge. Whatever I am telling, so you can apply on it. So I will give you a data example or Landsat 8, okay. And using this Landsat 8, you have to show me the FCC image, you have to show me the other band combination, like suppose I want to identify the urban region, then what type of band combination should be used for this purpose. Okay. Now thank you, and the band indices and band ratio, this is the session 3, and that will be followed by the 2 practical session. Okay. Now I am finished my.
We will move to the lab for the practical session now. So we will be having 2 practical sessions based on to whatever has been taught today for the theory. Okay, you all may know. Before that, yesterday we have created few groups. So I will add 1 extra member to each group, which was created yesterday. Just give me 2 minutes.
Can you please fill it, each person, your name and email ID, mobile number, organization and remark. How are you filling in the training program? Okay.